effects will cancel each other out in the calc. The simultaneous method also provides a means of measuring the coefficient of atmospheric refraction.
The least amount of error possible.
I'm not. I like just my superficial understanding of that would imply that the barometric and the temperature only really affect the consequence vertically, and if you're finding a measurement horizontally, shouldn't theoretically be affected. Oh. Okay, I'll have to shut up. I think I just thought of an idea. Oh yeah, there's something going on with the eyes then, but I wouldn't know how to explain.
Well,
does anyone else want to jump in? Yeah, go ahead.
If you do, there's actually in this book, it's pretty interesting. It talks about getting height measurements using theodolites, right? So there's single-ended trigonometrical heighting, reciprocal trigonometrical heighting, and simultaneous reciprocal trigonometrical heighting. So that third one is what's interesting, though. It says this, right? The observations are taken from each end of the line at exactly the same time in order that the curvature and refraction effects will cancel each other out in the calc. The simultaneous method also provides a means of measuring the coefficient of atmospheric refraction. I find that to be super fascinating.
Are they measuring that against the sky then? When they're taking this synchronous...
Simultaneous reciprocal trigonometrical heightings, right? So all 3 points are basically taking their heighting at the same time. And when you do that, you take out curvature and refraction effects in the calculations. So if you make a triangle, you cancel out curvature and refraction.
What kind of curvature? Do they mean Earth curvature or other atmospheric curvature, or like what? The context is important, because my understanding of reciprocal surveying and simultaneous means you basically have the tripod set as level as you can, and like 2 or 3 miles away you've got another one, and 2 or 3 miles, or maybe even more, to another one, that those 3 are sighting each other. The theodolite is angled down from horizontal to the other theodolite, and that means the reciprocal angles are not 90 degrees, which is problematic for approximately planar Earth. Yeah.
What? What are you talking about?
If the plumb lines are leaning
right
away...
Here, I'll post it. I'll post it for you, just so we're all on the same page here.
That 180 is an issue for spherical trig. You can't have 180 degrees with spherical trigonometry. I don't know why you keep saying you can't do it with right angles. Like, that makes no sense at all.
Yeah, I don't know. But dude, check that out. Pure.
With a big enough sphere, you can have 3 90-degree angles and a high.
Folks, you can't get 180 degrees with spherical trig. It'll never happen. You will never be able to do it. You can talk about it as much as you want, but you will be wrong in the end.
What do you mean you can't do it? You can do it on a golf ball. We do it on a snooker.
Did I totally misinterpret what they were saying? I think I did.
I don't know. I'm not sure, but
I don't think they know what they're saying.
They're still doing it vertically, aren't they? I thought they were doing it horizontal. I thought it actually kind of does impose, because you know how like a triangle, when projected upon a sphere, adds up to more than 180. So couldn't you just take 3 mountain points and do a measurement, and then if it adds up to more than 180 horizontally, then you can't. You can't?
You're completing a triangle. A triangle can't be more than 180 degrees.
Yeah, you're right. Because you're still doing it within a planar sphere. Yeah. Okay. My apologies.
But this is what's interesting. Pure, look at this. Look what it says here. This is what's so interesting. In simultaneous reciprocal trigonometrical hiding, right, where the observations are taken from each end of the line at exactly the same time. It's about kilometers away, right?
What paragraph?
In the live chat, in the bottom. It says curvature and refraction effects will cancel each other out in the calculations.
Usually exactly time. What are the curvature and refraction effects? How is that even possible?
Good question. That's why I bring this up.
Curvature and refraction effects will cancel. So they don't exist?
Read the top part. It says right there.
So with the calculation, curvature and refraction don't exist?
But listen how they preface it, right? They say, because the slope length of the line of sight between the points may be in the order of kilometers, it is necessary to take into consideration the effects of curvature of the Earth and the refraction of light by the atmosphere. Okay, so they preface it by saying it is necessary. Right. But when you do the third method, right, which is the most accurate method, the simultaneous method, it's called the simultaneous reciprocal trigonometrical hiding, right, that method, it cancels out the need to calculate curvature or refraction effects. Wild.
And why does it do that? Yeah, and why does it do that? By doing it simultaneously?
Because you're doing it at the exact same time. So you're basically having a true triangle, right? Because you're not taking an angle to a theodolite at a different time of the day where there could be different refraction effects.
Yeah, but this is refraction up and down. Not this has nothing to do with the spherical excess measurements.
But wait. But here's the thing, right? It says if you do reciprocal if you do the single-ended or the reciprocal, right? Just those two. You need to take into account curvature and refraction. But if you do it at the same time, right? It says you cancel out curvature and refraction effects. How can you cancel out Earth's curvature?
That's the problem.
Exactly. That's the weirdest part. And it's the most accurate method. It says right there, if Karis...
But say all you're doing like is 2 miles, right? Say whatever, 2 miles. We'll pick 2 miles. Okay. In that 2 miles, if one theodolite, right, say the light's bending down, right, looking from one point, why would the light not bend down looking the other way? You're looking through the exact same atmosphere.
Mm-hmm.
Why would refraction be deleted just because you're looking the opposite way? That makes no sense when you're like in terms of refraction. You're looking through the same fucking atmosphere, the same window of vision, just from a different, like the polar opposite angle. Well, not really, but yeah, you get what I'm trying to say, though, right? It's like going in a window, looking out the window, and then going on the outside and looking inside the window. That's all you're doing, and they're saying refraction doesn't happen if you do that.
Well, I get the refraction. Like they can say, okay, it cancels out the refraction calculation because you're looking at it at the same time. I get that. I want someone to explain to me how it cancels out curvature. Like, how does it cancel out? But it does both if you do it at the same time. It cancels out curvature and refraction calculations. You don't need to incorporate them. Isn't that interesting?
I guess you can make the argument for refraction. Oh, sorry, Rick.
No, you're right, man. I'm just adding to it. Go ahead, Pure.
I guess you could make an argument for how it would cancel out refraction if you validate. Yeah, but even then, if it's lining up,
if it's lining up, it's a true triangle, bro. It's
right, but what if it's lining up through refraction? What if refraction is what's causing it to line up? You will never know.
That's what the internal.
Unless you would take like a third point and then shoot from a third point to validate each station.
Well, that's why it says it is 3 points. It's simultaneous reciprocal trigonometrical hiding.
Oh, all right.
But it doesn't cancel out. The angles, and the angles are larger than internally than 180 degrees.
You just keep saying that over and over again. We're not even talking about spherical excess.
But that's how like the triple check works, is because the internal angles is different than what happens horizontally.
o'BL8, you don't have to make some weird, just incoherent answer, bro. We're just speculating right now. We're just talking.
I don't know if it's incoherent. It might be coherent to other people.
It's actually very incoherent.
It's incoherent to you. Other people may agree with me. I don't know. I haven't heard those voices yet. I only hear your condescending or rejection of my.
I'm just trying to save you the time, because I don't think you're saying anything really.
I'm
you
not
just
sure
keep
what
saying
he means by the 180.
The 180 it adds up over 180 degrees because of spherical excess. Like, we're not even talking about that. We're talking about this right now. We're talking about this surveying method right here with the Adelites and trigonometrical hiding, right? And my question was, how can they state that curvature and refraction effects can be canceled out of the calculations when you take it at the same time? When you take all the sight lines at the same time, right? 1, 2, 3. You're at 3 different heights.
Well, from my understanding, it's sort of the refraction is cancelled out as you do it both ways at the same time.
I would agree that there's error minimization, but I don't know if cancels out is.
It literally says it right there, verbatim.
Yeah. And
well, it reduces it to, like in your papers, that's down to, what was it, about 50 millimeters over a few some kilometers.
Yeah, it even says that simultaneous method. So when you do the simultaneous reciprocal trigonometrical hiding method, when you do that third method, it is the most accurate within plus or minus 50 millimeters of this of what are they using here? What do they say? They say it at the top.
So, yeah, and that's kind of like
these are measurement. Yeah, but these are measurements for elevation. Yes.
Yeah, I mean, if you read the whole chapter, it says if the reduced, it's talking about height measurement by theodolite, right? Trigonometrical hiding. And there's 3 methods you can use: single-ended, reciprocal, and simultaneous reciprocal.
It's like how people use language, like it cancels out, is a bit similar to like no one has done it.
What are you talking about, dude? Stop! You're just speaking nonsense.
You
no. I think the problem here is that what you do with these measurements is measuring elevations from one point to the other.
Right.
Not actually, you're not looking for the curvature of the Earth or anything. All you do is trying to figure out the change of elevation over distance.
Right. That's a big deal, right? Change of elevation over distance. So how can it be that
but you can also use this method. Yeah.
Oh, well, go ahead. All right, go ahead.
You could also use this method to measure reciprocal zenith angles.
Yeah, to the stars. Yeah, we're not talking about that right now.
No. That's not what I'm talking about. Reciprocal zenith angles. You can use theodolites and like this and add up the angles, and what you come up with, the results show that the plumb lines or verticals diverge over distance.
And just because
how
the
do you
word
know they
zenith
converge
is
over the distance?
involved doesn't mean the stars are involved.
That's exactly what they are.
What's an EDM system? It says,
an EDM reflector.
Oh, all right.
It says, they describe it in the earlier chapter. Hold on, let me go back up. Show you a picture.
It's like a beat. I don't know.
I'll show
like
you.
A
I'll show you.
receiver.
There's a picture in the book, but it's taking too long to find it. Here, EDM reflector.
Oh, you could just sum it up real quick.
I just want to show you what it looks like. So basically, it's a point that's on the theodolite that makes it easier to see. Let me show you. So that's like on the end of the theodolite. So if you put a reflector on your, like if you're using 3 theodolites, you put that on each one of them. That's how you could do the simultaneous method at the same time. I highly recommend like going over this engineering book because it's surveying for engineers, and they go over all the different types of scenarios and different effects of misaligning a theodolite, etc. But when I came across that, I was like, what the fuck? I still can't wrap my mind around it, so I'm not the only one, right?
Yeah, I'm
Like,
trying
how
to
can you
understand it.
cancel out
It's a
curvature
professional
and
field
refraction?
with professional equipment and skills. Yeah,
Oh, don't talk like that, man. Don't talk like that.
I'll talk however I fucking like.
Yeah, but you're
It's a professional
bloviating.
field with professional equipment. You wouldn't be able to understand it. Like, come on, man.
I'm acknowledging the skills of people who are able to do things. There's
No,
nothing
you're
wrong with that.
bloviating. You're just bloviating, bro. You're just speaking to speak. It's annoying.
You can presume that, but that's just your interpretation. You're pretending your interpretation is fact for everyone. Just like you said, no one has measured it. You read another thing and then say, this is what it says verbatim. So if you can play the verbatim against what they say, I can play the verbatim game against what you said.
You haven't
See, it's a
provided
double
anything
standard
except
you
the
have.
picture. Nah, dude. Listen, if you're actually paying attention, I'm asking for help on this interpretation. I want to interpret it the correct way. I'm trying to figure out what that means. That's why I asked it in the first place. I'm not going to just give some bloviating answer like, well, it's just because of the language, or it's just because the internal angles of 180 don't add up, and that's why it's spherical X. I'm just talk to talk. Like it's annoying, dude. You've been doing that all night.
You find it annoying. I'm sorry if that annoys you, but spherical access is a measurable thing. If you doubt that, feel free to try and measure it too. Like,
yeah,
there is probably a geodetic surveying company within 300 miles of you that you could make a phone call and like participate and ask, like, can you teach me or show me like why triple checked reciprocal reduces, minimizes, or perhaps cancels things. And I think they're accurate to about 15 inches is why the word cancels out. Because if you're a mountain,
you're just saying that.
If you're surveying a mountain and it's got a height of like something or other feet and 15 inches,
you know how the data is compiled? Like, say you did all this triangulation. Do you know what they do with the data after that to create the geoid? No, if you don't,
I've already posted an image of somebody who's done a survey.
Right.
So,
what did they? Wait.
Yeah.
I want to hear it. What do they do?
You recommended.
Yeah.
Yeah, if the surveyor you recommend I go talk to, I think you should just take your own advice and then go figure out what they do with the data.
Well, what do they do? Go ahead and explain it for us, though, because we were just talking about that.
Yeah, it's basically goes into the error propagation law, that goes into Taylor's law, and they kind of like when things don't match up, they get it to match up through statistics. What's the statistical likelihood of a measurement being true? And no matter what they do, they're going to end up with errors in the final result.
Yeah, error margin of measuring a 2,000 foot mountain to the nearest 15 inches is pretty good, I think.
Oh, so it's within 15 inches. Is that what you're saying? You're saying all these inaccuracies are within 15 inches? So you have no
I'm not
clue
sure if all of
whatsoever
them
what you're
are.
talking
Different
about?
surveying
Like zero,
techniques and different
like zero?
equipment would have different error margins.
Yeah, so that's the error margin to 15 inches. Okay, that's fucking brilliant that you just come up and pull this number out of
you
your
know what?
ass.
I'm incorrect, by the way. It's not
That's
3
what the
theodolites. It's
very
2
document
theodolites.
that he asked us to look at says. Like
Yeah, I'm not talking about. I'm
using
not
those
talking about.
geodetic datums and the ellipsoid,
Talking about
they
the
differ by
data.
15 inches. Like that's
So
from
they
the document.
predicted a shape, right? They took the data, they predicted a shape, but then they go out and do real world observations over and over and over, and the data does not match the shape. So
Not
they keep
exactly.
changing.
No, not.
Not
It
even
might be
close.
15 inches. It might be a foot off. Like why?
Yeah, it might be meters off. Yeah.
But hey, real quick, Pure. Check out what I found.
I'm not
So
sure
I
about
made
that.
I made a mistake earlier. I said they used 3 theodolites, a true triangle. That was incorrect. They actually only used 2. And read what it says about that.
That's what I thought I read.
Yeah, it says, since the sighting distances in each direction are also exactly the same, the effect of curvature is also eliminated.
Yeah, no. That's looking through one side of the window and then looking through the other side of the window. If the glass is warped one way, it's going to be warped the other.
I get that for refraction, but this is literally says the
Yeah.
effect of curvature is also eliminated.
Yeah, I recommend going through the entire documentation, not just quote
I
mining.
recommend the same thing. I recommend you go read like 900 pages of Helmer. Or you just start
How does
hand waving
Homer
every
help me
single
with
way that you
surveying?
can explain.
He's been doing that
You
all
don't have to
night, hand
understand how
waving,
your model was
dismissing.
built.
He's been doing that all night. He just does this all night. Like you just create straw men so you can try and beat them.
Anvil. Yeah, but so like we're having a topical conversation on the information provided, and you're telling us go defer to another authority and go ask them questions as an argument for the last, I think, 2 or 3 phrases that you've offered up so far. Either engage with the topic or say that you don't have an answer for it. But if your final answer is to go defer to some other authority that you would defer to, I don't know why you're engaging at all.
He just wants to talk. He just wants to
I'm
bloviate.
saying you can do the survey yourself. Like there is equipment available. Like there are like tutorials of like what an angle is, what an internal angle is. There are like tutorials of like how to correct for refraction and measure it. Like these things are
We're looking at the logic.
How to do this properly. No, you need proper training.
That's not.
Just watching
I'm not saying that. I'm not saying
you're going to be all over the place.
You can be self-taught. It just means like the people who are self-taught also like to self-teach them things about astronomy and take pictures of Jupiter that are reasonably high quality.
That's
like
fantastic.
just because you're an amateur and don't have a professional qualification, it's not an appeal to authority fallacy, which you're trying to slide me into. So
you're just
you
talking,
can pretend to slide me into the appeal to authority category, but that's just like you being manipulative.
Amble, I just want to say, you win any debate you had with me. You win 100%. I can see. Don't care to argue. Just nonsense. Okay. I just want to talk about what we're looking at in this paper. How's that? Is that okay?
Let's talk about what we're looking at then. But just
finally, holy shit.
But when I say the document says it's accurate to like 15 inches or a foot, I'm wondering.
Yeah, I already conceded that. I'm not going to argue it. Like, you know what I mean? Like, I don't know why you bring it up. I just don't want to argue. Like, maybe another day I'll argue about this, but I'm trying to understand this, and with you going on and on in the background, it's difficult. So, like, what I want to know is if I look north, right?
That it says verbatim it cancels out, but also the document says it's accurate to 15 inches doesn't mean exactly to me that cancels out completely to 0 is an accurate statement.
At this point in time, you're not having a productive conversation, Anvil. Let's just take a step back. Let us discuss this real quick, please.
Yeah,
but
so
you
I
do
want another
realize
pair of eyes on this.
your quote mine of
Oh my
saying
God.
this says verbatim that it cancels out, but also the document also says it's accurate to 15 to 20 inches.
Wrong.
You do. Are you sure? Like, keep on
Yeah,
reading
I'm
my
wrong.
document. I
Wrong.
am too.
Incorrect. It shows the accuracy error margin right there. Plus or minus 200 for the single-ended method, plus or minus 100 for the reciprocal, plus or minus 50 for the simultaneous, and that's in millimeters. So where are you getting this inches bullshit from? I don't know. You're just literally bloviating.
it's like what is that? That's less than 2 inches, right? Like,
Well, I
what
guess
is
they're
Is
more
this?
accurate than I
Yeah.
thought.
Yeah, and does it conform to
Oh,
differential leveling?
I was slightly mistaken about a number, and I can recorrect now, knowing that I have more correct
Are you
data.
even looking at the same page we're looking at? Here's the book. Here, follow along.
Oh, he's spoon
Please.
feeding me. Thank you so much for your spoon feed.
but now,
No,
Yeah.
it's
now if
called
we
being
only
on
have
topic.
if we
This
only
is
have 2,
just
right?
ironic.
We
You
have
put this spoon feeding narrative, and then I can just claim you're spoon feeding me. Like, it's just funny. Like, the mental gymnastics you do. It's just really interesting.
All right, can we talk about this? Like, we got the meta out of the way.
Please.
If you guys got to
What were you
get
gonna
more
say, Pierre?
updated out. All right, now, like, I thought it was 3 because I'm like, all right, well, 3, I guess you could validate.
I
And you're
thought
like,
it
yeah,
was
it's
3
3,
too, yeah.
but if it's only 2, then how can point A, right? If you draw a straight line, how can point A, right, not experience the same fraction? Like if you're looking A to B, how can B to A not experience the same exact refraction that A to B is having? Why would the light not do the same exact thing in both cases? And how
I
would
know,
you
dude.
know
How can it
if you're even
cancel?
lining up? Yeah, like,
But it does. I don't know. That's what they say. If you use that method.
So I guess with any, like, let's say bending of light, it's kind of like a bowstring or something. If you pull it back, it goes the same path forward as it goes back. I wouldn't expect a difference
right, you'd expect
if it's
it to
simultaneous.
bend one way.
The thing is that the elevation, since you do it both ways, what happens if you have the same refraction? The difference in height between the 2 points will be more accurate than if you do it one way, because then refraction will lift.
No, I totally agree with you.
Yeah, that's why. So it's not
But
actually
it says
having
curvature.
that much to do with the surface in that respect. What happens? It's just like the difference between the two then is just between those 2 points.
Yeah.
If you understand
And it
what I mean.
says,
Yeah.
yeah, no, exactly what you're saying. What I'm saying is, I get that for refraction. I don't understand how it's canceling out curvature. It says it
I
cancels
don't
out
even get it.
Yeah,
Yeah,
like
I
the
don't even
effect
get
of
it for
curvature.
I suppose. Yeah.
Well, for
Yes,
refraction, the calculations
are
for
they?
refraction.
Yeah, but they are just. Well, I don't know. This isn't geodesic survey, though, is it? This is just planar survey,
Just
but
hiding.
in rather short distances.
No, it says right here. Yeah, well, couple of kilometers. It says in the
that's
order
not
of
that long.
kilometers.
Yeah, planar surveys in normal use within what is 100 square miles, so 10 by 10 miles.
But the fact that it says the effect of curvature is also eliminated is what I'm puzzling. That's what I'm like. So
Yeah,
if you can take,
but this is geodetic. But is this geodetic or planar survey? I wonder, because I think that might have something to do with it, since it's such a short distance.
Well, if you get an elevation, it's going for elevation.
right. Exactly. Yeah, that's the confusing part. You
Yeah,
would think
because,
you'd
I
have
mean,
to take it into account.
You'd have to, yeah, you would have to.
You would think,
But
right?
it's
So
saying,
how does the
but yeah,
simultaneous method cancel the
but it's saying you
calculations?
become more accurate when you ignore these factors,
Yeah. Again,
which
that's another part.
is
Not ignored, cancelled out. It's like 1 plus
It's the
3
same
minus
shit.
3 equals 1. Yeah.
Yeah, that's
yeah,
okay.
essentially.
And that's what the
So
reciprocal
it's essentially
does.
not there. Yeah. Right?
And that's the same with going along the bowstring. You go forward and back, and so you've compensated both ways.
Yeah, but you experience. I don't understand that bowstring analogy. Because if the Earth's curving, you're looking around a curve, then the light's doing the same thing on that curve. If you're looking,
The light
you're looking
is
through it
doing
instead of.
something different more
So you
often
look
than
at
not.
it. So you could have refraction looking from A to B,
Sometimes
but not
the
B to A.
refraction is like 1/7, which makes the Earth look 7/6 or 8/7 larger. So it 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 lifts. It optically lifts something in the distance through the refraction.
Yeah. Or a sink. It can, like raise a sink. Yeah. But what I mean is, if like, all right, so if I'm standing with the object that is sinking, right? Right. If I am the object that's sinking, say you're looking at me, right? Off in the distance, and you're like, oh shit, this dude looks like he's floating in the sky, right? If I look back at you through that same atmosphere, shouldn't it look like you're floating in the sky and not sinking through the ground? Shouldn't you get the same exact effect looking through the same exact lens?
Yeah, that's like you wearing your glasses and then flipping your glasses around the opposite way and looking through them. You would still correct your vision because the lens doing the same thing for your eyes.
Right, so you still have the effects of refraction.
Apparently not.
Um,
And it's
Trying
more
to figure out
accurate.
why you want it.
they do exist, but the reciprocal means like that refraction is reduced to a level of precision that's, like you said, around 50 mil. Like that's what, 2 inches?
Yeah,
50
I'm just
mil.
trying to figure out how they get there is what I mean. Like, I can't work this out in my head. I can't
Dude, I
figure
know.
out
Well,
why.
imagine you got those 2 points, and from each side, and they both are refracted upwards the same amount.
Yeah.
Does that make it a bit easier to understand?
No, because I'm looking at a ball, right? Just I'm picturing like a ball, and then like a little piece of string, right? Like he explained it earlier, like a string curving around that ball perfectly. Or like even a dinner plate, you just put the string going with the edge of the dinner plate, right? And you put it like an inch off or whatever, like 1/4 inch off the plate, right? So now you have that string represents your light and how the light is bending. If I stand on anywhere, right, I pick 2 points on that plate, the radius of the plate, then
Looking at each other, right?
yeah, pointing towards each other. That string is
Should
going to
have
be doing the same thing for both observers.
correct.
And that's where I'm like bricked. I can't move past that because I can't figure out why it would
How
change.
do they cancel out? Yeah, dude, I've been talking. I found this like 2 years ago, 3 years ago in this discussion. I still struggle with it. I just find it fascinating because I'm like, how can they say that essentially horizontal and level lines are the same for most survey work because you can ignore curvature and refraction. And I'm like, okay, how? Okay, simultaneous reciprocal trigonometrical hiding method or whatever. So you're looking at it at the same time, one end on one end, or one theodolite on one end, and then another theodolite on the other end. I thought it was a triangle. Like I was trying to work it out. Oh, maybe I could see it as a triangle, but reading further into it, I didn't know that it was just two of them, which makes the conundrum even more apparent. Because it's like, what? How could you say that there's refraction effects with just one site, but if you use two of them looking at each other, there's no refraction effects, and not only no refraction effects, no curvature. The effect of curvature is also eliminated.
But don't you? But think about it. You have 2 points, and both of them are refracted upwards equally. So if you measure the elevation change between the two, then you can sort of eliminate refraction because they're both lifted up in the same amount.
Okay.
So basically, what you do, the only thing you're doing then is actually measuring the elevation change from point A to point B, or from point B to point A.
Right. So how is the effect of curvature also eliminated?
That one I'm not so sure about, but it says only a few kilometers. So because this is tied into differential leveling, I see they use it as a extra mean to control the differential leveling, and differential leveling does not take the curvature of the Earth into account when you do that. That could be one of the reasons.
I mean, this is just hiding, though. This is just talking about elevation changes, right? Hiding from one theodolite to another theodolite. You know, and we heard arguments all the time about, you know, Jesse Path of Light's theodolite measurements. Oh, it's 75 miles away, and look at it bend. It matches the curvature of the Earth.
Yeah, but the measurements we're talking about there is only a few kilometers, or 1, maybe 2 miles at max, as well within what you call a planar survey.
So how does that logically compute that if you only use a single end, you have to take into account curvature and refraction, but not simultaneous?
In planar surveys, short distances, they usually don't take Earth curvature into consideration. It's mostly, it's when you get to really long distances, that's when you geodetic survey. That's when you have to take Earth curvature into account.
Yeah, that's when the tool stops working, though.
I was just about to say, yeah.
The tool stop. Oh, you mean like in planar surveying, where you use a rod, a measuring rod? Yeah. Well, you can only discern the markings on the rod at the specific distance, but you can without that a mountain peak or something, you can use it on much longer distances. That's no problem.
I don't know. Found it fascinating, though. If you can figure out any more on this, Pure, let me know.
Yeah, I guess the refraction you could just say the difference, right? But you're not going to get small elevation. You'd have to. Where do you ever get the point where you establish that elevation in the first place? You can get an elevation difference, but yeah.
Well, I mean, they talk about when you would use this method. You would use this method for like a hilly area with unknown heights, right? But starting at 1, you could start at anywhere in that hilly area. Like, let's just say it's 20 feet high. You go from there, and you put a theodolite on top of the next mountain, a kilometer away or whatever, and you're trying to measure the height difference, the elevation change from that mountain, like
You
let's say
can't
that
even
hill to
do
that
that,
hill.
though. You can't do that. It just doesn't work. All you're saying is like this theodolite is X inches or meters in this case, X meters above the other one. It's like
Above the
okay,
other one, right?
right? It's like
Yeah.
okay, well,
Oh,
what's the
When you
distance? What if you're a mile out? Then you have your drop over distance, and it's like, whoa, well, what the fuck?
You should
Like,
have
why are
it.
you not calculating that?
Yeah, exactly. So how can the effects of
Like,
curvature be canceled? But
and if refraction's affecting all of that, then well, you're just up shit's creek. But I'm
There
trying
is
to
an
figure out.
explanation. There is an explanation of what the difference is. Is that with a single ended, you've got all the factors to take into consideration to correct for, and it's simultaneous. They're not actually saying it's done at the same time necessarily. They're saying it's done from one end and then the other, reciprocal in that respect. They're not sorry, the non-simultaneous. They're saying that measurements are done back one way and the other, and the inference
right.
there is that in most of those situations, they may be done at different times. And the theodolite to site position locations may alter slightly or may be a bit different, but they nonetheless they go back at each other on effectively along the same track. The simultaneous one is what's used in the reciprocal zenith angles. Now in that you use the same
You can't
factor
do
to
that in your mountains.
Okay, sorry. Where
Go ahead.
interrupt
I'm
me to
sorry.
say that?
Go ahead.
With the reciprocal, the simultaneous reciprocal, which is what's used for you've seen in all the classic reciprocal zenith angle measurements. You have a because you know that the conditions are the same going, in the space between you. You can use the same corrective mechanism for the refraction, but also because you know the distance is exactly the same because you're sighting against each other at the same time. That's how you can calculate out the curve. It says so in the text in the next section if you care to read.
So wait, hold on. What's that last sentence? How does it cancel out the effects of curvature?
It's in the text, and read 2 paragraphs down from the bit you're transfixed on, and it'll give you an explanation as to how you can correct for the 2 components.
Yeah. Okay. How is the effect of curvature also eliminated? How?
Because by the very nature of the 2 measurements are done with exactly consistent distance, you can correct for the curvature. It doesn't say there's no curvature in the observation. It's talking about corrections you make post observation.
Since the sighting distances in each direction are also exactly the same, the effect of curvature is also eliminated.
Yep.
Okay, how?
What do you mean how? Because you use the same equations used that's used in the reciprocal zenith angle to know the deviance from plumb. When you know that, you can take that out. You then know the true elevation difference between the 2 positions. This is what they've been banging on about when they talk about reciprocal zenith angles here and everywhere else for 2 years. This is the essential aspect to take on board. Deviance from plumb, which is something you derive from simultaneous reciprocal measurements, means you take when you know that deviance, that's your angular deviance for the curve. That's what they're taking out. Once you've taken that out,
you keep talking about plumb.
Once you've taken that out, you can refer back to the elevation differences in the observation. That will give you a true elevation difference if you stood on a curve.
You keep talking about plumb, but it's not off plumb. It's off your horizontal.
Okay, you can keep saying that to you blue in the face.
No, you have mass. Mass attracts mass. Like that's the reality. You're in like a mountainous region now doing these measurements to get elevation differences. You're gonna have mass attracts mass. You're not gonna have plumb.
What do you think reciprocal? What do you think zenith means in reciprocal zenith angle measurements?
I don't think you listen to what I'm saying. You cannot have a true plumb when mass attracts mass. So you cannot refer to your plumb bob if your plumb bob is deviating because the mountain is causing your plumb bob to sway in its direction. So therefore, you need to refer to your horizontal.
No, you don't. No, that's not true.
Okay. Okay.
No,
you don't.
Now
mass it doesn't attract mass. Okay.
Well, no. What you need to do is to evaluate how much deviance from plumb a local mountain will cause it compared to the mass underneath you. And secondly, The whole point about this is that you are measuring the deviance between two relatively distant points. The fact there is a deviance between them speaks volumes, and it's geometrically consistent across the entire realm we live in. That speaks volumes. There are local differences from that geometry, but compared to the actual overall.
Yeah, and when dropping a plumb bob and doing these things, like everybody likes to argue. They like to talk about like, oh, I just dropped plumb. That's how I established my my zenith angle. It's like, well, no, you're on a mountain now. What do you do?
Okay, so
you don't have plumb.
So how much?
So what do you do?
How much can?
No, I'm
how
asking
much
you, what do you do?
Well, I'll ask you this: how much?
If you're on a mountain, you drop plumb. You know your plumb bob's going to deviate. You have no way to tell how much, right? Without presupposing something. So what's the next step?
No,
you refer to what? Horizontal?
You can measure that.
When you say on the mountain, are you saying on the very top where there would be the least deviance, or on the side of the mountain where there would be more deviance?
You're doing an elevation height, right? So say you're next to a mountain,
right?
Say 2 kilometers from a big ass mountain, right? You're at the base of the mountain, like where it starts to go up. You're trying to do an elevation height there.
Right. So how do we ascertain what the deviance caused by the mountain? Because we could, if it was significant enough that we could actually measure it, and let's suppose it is. How would you measure it?
You refer to your horizontal.
Or you could refer to something much more consistent, which you could simultaneously observe.
More consistent than horizontal.
Right? Yeah. There's something you can use with optics, which would give you a far more accurate understanding of an angle to horizontal, simultaneously from two locations, rather than referring to a bubble height or observation of the horizon. What would that be?
I don't know. You don't have plumb.
A star. You could use a star. Simultaneously.
No, you can't. Oh my goodness, guy.
Yeah, you can. Yeah, you can.
Why are you going to look at a star?
How are you going to establish horizontal on the side of a mountain? How are you going to do that?
With a fucking level.
What?
With a level.
Okay, level. What's level?
Horizontal.
Bubble level?
Just remember, plumb is often 90 degrees to plumb.
Okay,
so even your water level would be
perpendicular. Right?
You couldn't use
perpendicular.
No, but your bubble level, will also be kicked off by the same amount as your plumb. You understand that, don't you?
Why?
Why? Because it's working on buoyancy, which works on the same mechanism that works on the plumb. Liquid would be displaced the same way as the weight on the end of the plumb bob. It's working in the same gravimetric context, isn't it?
It doesn't say that in any of the. It doesn't say that in any of the handbooks.
Come on, my man.
It doesn't.
You can't work.
You're just putting that out there.
You can't